Hello viewers, I am Manavjyoti Choudhury, Assistant Professor in the Department of Computer Science and Engineering of Assam Downtown University. In this video, I am going to talk about the FCFS disk scheduling algorithm. Disks provide the bulk of secondary storage for modern computer systems. Modern disk drives are addressed as large one-dimensional arrays of logical blocks, where the logical block is the smallest unit of transfer. The size of a logical block is usually 512 bytes, although some disks can be low-level formatted to choose a different logical block size, such as 1024 bytes. The one-dimensional array of logical blocks is mapped onto the sectors of the disk sequentially. Sector 0 is the first sector of the first track on the outermost cylinder. The mapping then proceeds in order through that track, then through the rest of the tracks is in that cylinder, and then through the rest of the cylinders from outermost to innermost. The number of sectors per track has been increasing as disk technology improves, and it is common to have more than 100 sectors per track in the outer zone of a disk. Similarly, the number of cylinders per disk has been increasing, and several thousand cylinders is not unusual. One of the responsibilities of the operating system is to use the hardware efficiently. For the disk drives, this means having a fast access time and disk bandwidth. The access time has two major components, the seek time and the rotational latency. The seek time is the time for the disk arm to move the heads to the cylinder containing the desired sector. The rotational latency is the additional time waiting for the disk to rotate the desired sector to the disk head. The disk bandwidth is the total number of bytes transferred divided by the total time between the first request for service and the completion of the last transfer. We can improve both the access time and the bandwidth by scheduling the servicing of disk input-output requests in a good order. Whenever a process needs some input-output operation to be performed to or from the disk, it issues a system call to the operating system. The request specifies several pieces of information, such as whether this operation is input or output, what the disk address for the transfer is, what the memory address for the transfer is, and what the number of bytes to be transferred is. If the desired disk drive and controller are available, the request can be serviced immediately. If the drive or controller is busy, any new request for service will need to be placed on the queue of pending requests for that drive. For a multi-programming system with many processes, the disk queue may often have several pending requests. Thus, when one request is completed, the operating system has an opportunity to choose which pending request to service next. Now, let us have a look into the FCFS, or first come first serve disk scheduling algorithm. The FCFS scheduling algorithm, disk scheduling algorithm, is the simplest form of disk scheduling. This algorithm is intrinsically fair, but it generally does not provide the fastest service. The problem with this schedule is let us consider this scheduling algorithm with the help of an example. Let us consider a disk queue which requests for input-output to blocks on cylinders 98, 183, 37, 122, 14, 124, 65, 67, and so on in that order. If the disk head is initially at cylinder 53, it will first move from 53 to 98, then to 183, then 37, 122, 14, 124, 65, and finally to 67 for a total head movement of 640 cylinders. The problem with this schedule is that the while swing from 122 to 14 and then back to 124. If the requests for cylinders 37 and 14 could be serviced together before or after the requests at 122 or 124, the total head movement could be decreased substantially and performance could be thereby improved.